Sometimes you might be given a problem when you have the function group, for example, the Br jumping from one carbon to another. So if we number the carbons here, we can see that it's going from carbon number 1 to carbon number 2. And so these are actually very common and useful in organic synthesis, and you do want to be able to understand that. So let's see how that works. As confusing as it may look, you need to remember that anytime this is happening, you can use this simple approach. If my functional group is moving from the right side to the left side, I can just put an arrow and try to follow that direction. How do you follow the direction? Well, the principle here is that you want to introduce a double bond. Because if you have a double bond, for example, we put this unsymmetrical double bond, I can add any group. For example, I'll just put a Br here. I can add a Br on this side, and I can also add a Br on this side as well. So remember, this is more substituted, so this is the Markovnikov position, and this on the right side in this case is less substituted, so this is the Anti Markovnikov position. And we can use different conditions to put the function groups on a double bond, whether following the Markovnikov rule or the Anti Markovnikov rule. And so that means that we're actually able to move the position of the functional group, either going from the left to the right or right to the left. So keeping that in mind, let's see how we can figure this out. So step number 1, you want to introduce a double bond right here. And actually in this case, we don't have any other place to put a double bond, because this is the only carbon connected to the bromine. To achieve this, number 1, you want to treat this with a strong base. For example, we treat this with sodium ethoxide. And this will give us this alkene with 4 carbons, so 2, 3, 4. And the double bond is going to be on this terminal side. That is happening by the base attacking the beta hydrogen. So remember, there is a beta hydrogen here. And this is a base that is attacking, breaking the bond, making the double bond, and loss of the leaving group. Now, once we have the alkene, we can identify the Markovnikov position, so that's more substituted compared to the one on the right side. And here what we do is a simple hydrobromination. So HBr is going to put the Br on the secondary position, because the secondary carbocation is going to be more stable than the primary one. And so the Br here, and this will be the product that we are aiming for.